Flow of absorption solution in cooling. Absorption solution drops from the tray on the upper part of absorber onto heat transfer tubes inside absorber and gathers at the bottom, absorbing refrigerant that comes from an eliminator. At this time, absorption solution becomes much more diluted than before it has flown onto the tray. Concentration is about 58% under normal operation as shown in the diagram. It is called diluted solution. The temperature of diluted solution gathered becomes high, about 120–130 degrees Celsius, exchanging heat via the low-temperature heat exchangers, heat reclaim and high-temperature heat exchangers, and the diluted solution goes up to the high-temperature regenerator by absorption solution pump. Absorption solution, of which concentration is about 61%, is referred to as intermediate solution. This intermediate solution passes through the high-temperature heat exchanger, lowering the temperature of intermediate solution, about 94 degrees Celsius, then goes up to a low-temperature regenerator. Absorption solution is transferred from the absorber to high-temperature regenerator by the discharging power of absorption solution pump, and on the other hand, from high-temperature regenerator to low-temperature regenerator, it is transferred by pressure difference between those regenerators. Pressure of high-temperature regenerator is almost 710 mm of mercury, and that of low-temperature regenerator is about 56 mm of mercury as shown in the diagram. By means of this pressure difference, concentrated absorption solution in high-temperature regenerator is delivered to a low-temperature regenerator. In low-temperature regenerator, hot refrigerant vapor which is separated out of high-temperature regenerator passes through heat transfer tubes, heating intermediate solution to make it more concentrated, about 63%. It is the most concentrated absorption solution and is called concentrated solution. Absorbed solution, which has become concentrated solution at the low-temperature regenerator, returns to the absorber in lower temperature, about 52–55 degrees C, passing through low-temperature heat exchanger. Absorption solution flows into the absorber by means of height or pressure difference between low-temperature regenerator and absorber. Absorption solution is circulated absorbing refrigerant again in the same way. Circulation of refrigerant in cooling. Refrigerant, which is vaporized in evaporator, cools water in the heat transfer tubes. Vaporized refrigerant is absorbed to the absorption solution and separated from the absorption solution in the high-temperature generator. Then, the evaporated refrigerant vapor goes to the low-temperature generator following the refrigerant vapor pipe. Vaporized refrigerant from the low-temperature regenerator flows into the heat transfer tubes in the low-temperature regenerator. At this time it works as the heat source, heating the absorption solution, which is intermediate solution. Vaporized refrigerant, which has passed the low-temperature regenerator, heats absorption solution and is condensed into liquid. Condensed refrigerant moves to condenser, then returns to evaporator, and the remaining refrigerant vapor which was not condensed in low-temperature regenerator will be condensed by cooling water in condenser. Refrigerant in condenser returns to evaporator and will be circulated as above.